How to choose an optic fiber fusion splicer. Another factor that determines the accuracy of optical fiber alignment is whether the lens can achieve fiber core alignment. Although theoretically, the core of the optical fiber should be in the center of the fiber. Due to the different production quality of each optical fiber manufacturer, the core of some optical fibers is not in the center of the fiber. There will be a certain deviation. Currently, there are two types of cameras. One that can only see the cladding of the optical fiber, and the other that can see both the cladding and the core. If the amount of splicing is very small, and there is no requirement for loss, cladding alignment is sufficient. However, if it is for operators, railways, engineering companies, and business companies to construct optical cable lines, maintain lines, emergency rescue, security monitoring, and teaching research, it is recommended to choose core-aligned ones. It is recommended to choose AI9, AI20, and AI30 series from Juoshi, or imported high-end models. There is a large price gap between these two different lens types, and users should carefully consider the cost-effectiveness based on their business scope. In addition to alignment accuracy, the most important factor affecting the quality of optical fiber fusion splicing is fusion discharge. Theoretically, the splicing process is divided into dust removal, pre-melting to soften the end face, overlapping splicing to connect the optical fiber. However, in the actual splicing process, due to factors such as vibration, optical fiber impurities, arc impact, etc., the optical fiber will have jitter, misalignment, and power changes at the moment of discharge, which will lead to increased welding loss and insufficient splicing strength. Low-end fiber fusion splicers are usually unable to capture image changes in real time during the discharge process. Perform recalibration and adjust the current. However, high-end fiber fusion splicers can collect up to hundreds of real-time images of optical fibers during the discharge process and adjust the position of the fiber core and the current intensity at any time to achieve the best discharge welding effect. Therefore, the computing power of low-end splicing machines and high-end splicing machines is completely different. Currently, Signalfire's AI20, AI30, and some imported high-end models all have this capability. With the current production cost, it is difficult to have the necessary hardware configuration for this capability at a price below $570. In the next issue, we will take you to learn about supporting tools and intelligent maintenance.